The objective is to determine the weight of an object by constructing a vector diagram of the forces acting on the object. For the material and apparatus is Newton scales, strings, board and paper, protector, ruler, slotted weights, weight holder, and pointer.
Assalamualaikum. My name is Muhammad bin KAMARUZAMAN. Now I will continue our presentation with methodology of vector experiment. First methodology is methodology for lab activity. First, set up the apparatus as shown in figure 1. Make sure that both Newton scale are set to 0 Newton. Second, hang the 10 gram weight holder to the node. And third, place the center of protector behind the node. And fourth, place the pointers behind the string to record the angle. And fifth, determine the force of each string. Tabulate the result obtained in table 1. And sixth, increase the mass by adding 10 gram, 50 gram, 100 gram and 150 gram slot weight to the weight holder. And 7, repeat step 4 and 5. Next, methodology for simulation. First, set up the apparatus as shown in figure 2. Make sure the magnitude of both hanging weights are the same. And second, select the first object, which is wood, and hang it at the center of the board. And third, insert 50 gram hanging weights at both sides. And fourth, press the center of protection and then record the angles and values of tension as in figure 2. And fifth, repeat step 3 and 4 but increase the mass for both sides. Repeat the experiment with other objects such as steel and stone.
So I will continue with results and data analysis. For the first table, it is based on what is being given by our lecturer. According to the table, 10 gram, 50 gram, 100 gram and 150 gram is added at the weight holder. The angles and the tension also be calculated and recorded into the table. So this is the result for based on the simulation for wood, starting from 50 gram weight holders, 60 gram weight holders, 70 gram weight holders and 80 gram weight holders. Using the same amount of weight holders, replace the object with steel and you will get a new angle and tension. Replace the object with stone and you will get a new result for angle and tension. So there are a few sources of errors during the process in this experiment. The first one is there might be an extra friction in the pulleys. The weights might not be accurate and the points may not mark correct.
For the discussion, on the basis of data, the weight value which is n obtained is 98.2 Newton, which is similar to the theoretical weight value of 98.1 Newton. Error in measuring could be to blame. In the experiment, there are two possible errors that could occur. First, there's the parallax mistake, which occurs when a measurement is made and read by the observer in the wrong place or when a faulty measuring system is utilized. Then there's the spontaneous mistake, which occur as a result of random changes in the status of the experiment. To avoid this mistake, precaution must be taken. Two approaches to reduce the mistake in the experiment are to place the eye perpendicular to the meter reading. Another method is to calculate and take the average value as a result of repeating the experiment and reading the computation twice or more to reduce the experiment's error. For the conclusion, finally, the calculation diagram and actual experiment result in the magnitude and direction of the resultant force acting on the particles being calculated by sketching the vector diagram and the particles being in equilibrium when the resultant force is zero. The objective is to determine the magnitude of the gravitational acceleration during free fall. The apparatus is drop box, communication cable, time of flight accessory, control box, AC adapter, steel ball, timer switch.
Assalamualaikum. My name is Muhammad HAIKAL bin KAMARUZAMAN. I will continue our presentation with methodology of free fall experiment. First methodology is methodology for lab activity. First, set up the experiment as shown in figure 1, and second, attach the object to the drop box, and third, place the time of flight accessory directly below the object, and fourth, switch on the smart timer, and fifth, press the select measurement button until time appears on the display, and sixth, press select mode button until two gates appear on the display, and seventh, press start and stop button once to release the object and to reset the record reading. 8. Take the timer reading, and 9. Repeat the experiment several times with different height. Record the high and drop time in given table 1. And 10. Repeat step 2 until 9 for two different types of objects. Record the high and drop time in given table 2 and table 3. Next methodology is methodology for simulation. First, select the height of the ball and press drop. Record the time generated, and second, press reset before repeat the simulation with different height. And third, record the height and drop time in given table 4.
This is the result based on the experiment of golf ball, mass of 46.03 gram. Using the same height of the ball from golf ball, change the ball into steel ball, which has a mass of 65.95 gram. Results for table 3 is done by plastic ball, which have a mass of 36.2 gram with the same height. Last but not least, table 4 is done by simulation, which have a height of 10 meter, 20 meter, 30 meter, and so on until 100 meter. The time drop then be calculated and recorded into the table. Based on the value calculated in the table, draw a graph for each table. So this is the graph for table number 1. This is for number 2. And this is for number 3 and number 4. Next, find the gradient for each graph. From table number 1, you will get 4.74 meter per second square. For table 2, you will get 4.69 meter second square. And from graph 3, you will get 4.73 meters second square. And for the graph number 4, you will get 4.95 meter per second square. Using the formula of gravitational acceleration, G equals to 2 times the gradient of each graph, you will get 94.48 meter second square for table 1 and 9.38 meter second square for table 2 and 9.46 meter second square for number 3, and number 4 you get 9.9 meters second square. So for the first discussion, by using the percentage error, compare the calculated value of gravity with the standard value. You will get 3.27% for table number 1, 4.29% for table number 2, and 3.47% for 3, and 1.02% error for table 4. There are a few factors that contributes the difference in the value referring table 1, 2, and 3. So for the first one is the mass of the balls, which is the heavier the ball, the higher the shorter the time taken to fall. And the second one is parallax error, when the position of the eye is not perpendicular to the scale. And to overcome the factors, you might want to use the same mass with different balls instead of different balls and different mass, and make sure the eye is parallel to the scale's reading to avoid parallax error.
For the conclusion, a freely moving steel ball was timed to determine the acceleration due to gravity. The value obtained by fitting the data with least square produced G equal to 9.56 meter per second, which is slightly less than the conventional value.